So let's look at takeoff then. We're going to be using now graph 2.1, which is for SEP, and we're looking at a takeoff graph just to give you a look around what's on these graphs. So to start with, we've got associated conditions. Every single graph in the CAP will tell you what associated conditions are being used. Some of these are obvious and some of them really are not. So it's really worth getting into the habit when you use a graph, start by looking at the associated conditions, because there are some graphs, particularly for Perf A, where there are duplicates of the same graph, and the difference is the associated conditions. So by getting in the habit of reading them before you use a graph, you will avoid going through the graph correctly but still getting the wrong answer because you're on the wrong page. Okay, so really discipline yourself to start by reading the associated conditions. Next, there'll be an example, and this example is the best piece of homework there is because it tells you the answers as to how to use the graph. So on every graph, or nearly every graph, there is an example of how to use it with dashed arrows showing you the direction that data is used to get through the graph. So in this case, we've got the example up the top there, and then we've got the data that's being used down here, and going through to show you how the data has been arrived at. And we come across with reference lines, and we come out at the other end with the data that we need, which in this case was the distance to reach the ground roll and to get to a 50-foot obstacle height. And other data on the table, sometimes plonked in a separate subgraph, as here, where we've got simple takeoff speeds table, which, by the way, we do not need to interpolate. It's just use the next one up. So that's the outline of how these graphs tend to work. They're nearly all the same process. So if you can use this sort of graph, you can use any sort of graph. And the whole point of aircraft data is that you do not need to study carefully how to use a particular type of data, because all the data must be clear, which is why these little tools are always there to show you how to use it. So don't be scared of these graphs. They're actually free questions. They are marks that you can gain with no knowledge, because all you have to be able to do is read and to use a ruler and a pencil. So do not be scared of them. Be grateful that they're there. Okay. So no interpolation for those speeds, and that's often the case, and that's because if you look at them, nearly all of them are only 1 knot apart, and so it's not necessary. You just round up to the next speed, and that's good enough for the exam questions. So finding takeoff distance and ground roll, this is similar for the SEP and the MEP. We're going to start by using an example here. We've got outside air temperature of 22 degrees, so I've gone in, and this is the good technique to get into. Take all the data from the question and put it into the graph first. So instead of trying to work across the graph left to right, don't do that. Work through the question, find the data in the question and put the line in the graph. So in this case, 22 degrees, pressure altitude 8,000. So I've drawn from 22 degrees up to 8,000 feet. We then go to the next piece of data, which is 3,400 pounds. The next piece of data is a 15 knot headwind component, and we've got all the data out of the question on the graph. The reason we do this is it's faster. It's much faster, and it's less prone to missing items out. And because of that, you save exam time, and exam time gives you the opportunity to think more about what you're doing and to review your questions more carefully at the end. So it's a really good trick to go through in this process. Question data first, then fill in the gaps. So in this case, we've got all our data in. We know that we have to go from 22 degrees and 8,000 feet. So we simply go across to the reference line. And we start there every time because we're following the direction of the arrows. So if I just pull up my laser pen and I go to the arrow here, this is the example arrow that was given. And if you look at this arrow here, we can see that we're going left to right across this graph. So if we're going in the same direction as the arrows, we always start by going to the reference line. If you're going the other way, and sometimes we do, and we'll be looking at that later, then you have to go to the reference line, to the guideline adjacent to the data, and then follow the guideline back to the reference line. And we'll be practicing that a little later on. So we carry on from the reference line, we follow the guideline down to our data. We then carry on straight across to the next reference line. We follow the guidelines down to the data. We then go across to the next reference line. And in this case, by going straight through to the right-hand scale, we can find the takeoff run, or the takeoff roll, And by going from the reference line up to 50 feet, we can find the takeoff distance. Remember, for perf B, screen height is 50 feet, not 35. 35 is only for perf A for takeoff. So screen height's always 50 feet. And again, if in the exam you get asked about screen height and you can't remember which one's which, remember that in your annex, in your workbook in the exam, you will have graphs. In those graphs, you will almost certainly have SEP or MEP. And by looking at the takeoff graph, you can see that it's 50 feet. So if you forget it, there's a reference there you can use as a crib. There's a note up here which is worth noting, which says guidelines are not applicable for intermediate obstacle heights. They only work for two numbers, for takeoff roll at 0 feet and for takeoff distance at 50 feet. Okay, simple as that. The big thing people make mistakes on with graphs is misreading of the scales. So make sure that when you look at the scales, you read them carefully. They're not all the same. So in this case, for example, the degree C scale has got increments of 2 degrees per square. If you then go to the mass scale, you can see that it's got increments of 20 pounds per square. And if you go across to the wind, you can see that it's 2 knots of wind per square. Every graph tends to be slightly different. So you must check the scaling or the graduation of each scale as you go. Again, we now go to the end and we've got our takeoff distance and our takeoff roll. We then can go to the subtable at the top and going in with our weight at 3,400, so we can come out with 71 knots, rotation speed, 82 knots at 50 feet, ground roll of 2,100 feet, and takeoff distance at 3,900.